Okay, good morning, everybody. My name is Gherardo Chirici. I teach forest inventory and remote sensing at University of Florence. I have a forestry background, but I do remote sensing since my PhD, well, more than 20 years ago. Okay, so let's start with some basic information. I will go quite fast because I think this information are well known by this audience, but just to remember that we can manage our forest depending of the different conditions, environmental conditions, social, economic. So we have a kind of gradient between the extreme natural old growth conditions where we try to maintain our biodiversity, to the extreme on the other side of forest plantation that are mainly devoted for food production. So to do so in a sustainable way, we need information, and the information in this moment in most of the countries are coming from national forest inventories. So this information usually to guide forest planning are not coming from remote sensing, but are coming from field observations that sometimes are integrated with Earth observation. This is what I'm going to talk about. So to understand the sustainability of forest management, we use a very traditional approach. There are many indicators for assessing the sustainability, but one of the most used is quite old. It's coming from the 18th century, from von Karlowitz. So the concept is related to the ratio between increment and fellings. So the golden rule of forest planning is that we don't have to harvest more than the increments. Otherwise, we are losing our forest in the long term. So this is a typical example of the information that we need from forest. So this is what is done in Europe by the Forest Europe, so the former ministerial conference on the protection of forest in Europe that provide information of the ratio between harvesting and felling. So you can see that most of the countries don't cut more than the increment, with some exception where they cut very close to the 100%. So this information are traditionally coming from field observation. So in the past, there was only one way to collect information. That was the so-called compulsory forest inventory. A compulsory forest inventory is based on the concept of census. This means that we collect information on the whole forest. But this is extremely time-consuming and extremely expensive. So more in the modern age of forest inventories, we use the sampling theory. So of course, we don't have time here to go in detail, but I think it is important to understand a little bit more regarding the sampling theory to understand how to use Earth observation products in a consistent way. So the sampling theory means that we have our universe. Our universe is the full forest, the whole forest we have in a given country or a given region. So we are not collecting information for the whole forest because this is too expensive, but we are extracting a sample, and the sample must be random, okay? So this is the basic assumption. This is a very famous paper from Horvitz and Thompson, very well known. So nowadays, all the national forest inventories in the world use somehow what we call Horvitz-Thompson estimator. We don't have time to go in details of the Horvitz-Thompson estimators, but just some information that we don't just calculate the estimation of the forest variable, for example, the forest growing stock volume or the basal area, number of trees per hectares or whatever is the variable that we want to estimate, but we have to calculate the variance. This means that we have to calculate, we have to evaluate the precision of our estimation. So it's what we need for forest planning is not just the estimation itself, but we need an assessment of the error of the estimation. So this is very important for our Earth observation application. Just to understand a little bit better what I mean for calculating the variance of the estimation. For example, this is a very well-known example. So the question here is, what is the area of the purple color? So this is a very strange polygon there, so it's very difficult to calculate the area. So what we can do is to estimate the purple area. To do so, we create a sampling design. Then we put a square grid, for example. This is a way of extracting a random sample, okay? It's a systematic random sampling. So we then calculate the number of plots falling in the purple, and then from we arrive to this ratio. This is the Hurwitz-Thompson estimation of the purple area. But what we can do with the Hurwitz-Thompson estimator is also calculating the standard error of the estimation. So we have, using this sampling design, we have the 7% of standard error of this estimation. What we can do to increase the estimation, the precision of the estimation, is to create a more dense grid. So I will have more points to calculate the purple color. And so at the end, I have the same estimation, but with a higher precision. So this time I have the 3% of standard error because I have a higher number of points. So this is just to understand you the basic concept of the Hurwitz-Thompson estimation that is used also in all the national forest inventories. Of course, the sampling design, the methods are more complicated, but the basic concept of the sampling is the same. So please remember, we don't need only the estimation of the variable, but we need also the assessment of the uncertainty of the estimation. So let's go now to the Earth observation component. So we all know that we have a lot of products coming from the Copernicus system, especially the Sentinel-2. The Sentinel-2 satellites are providing a very rich time series of observation, but we have many other satellites. The Sentinel-2 is collecting, for example, well, this is old already because this is with the constellation of 2 satellites. We know now that we have 3 satellites, so we have an even more frequent acquisition of this data at 10 meters resolution. So a lot of data available for our application. So what we have to do now is to have an infrastructure for elaborating all this data. So this is where WEkEO is coming for helping us. So in the past, we had a lot of approaches, but in the different countries, of combination between the national forest inventories and the Earth observation to create wall-to-wall maps of forest variables. So at the end, we need 2 sets of data, 2 types of data, the data coming from the remote sensing platform and the data coming from the field observation, from the sampling design of the National Forest Inventory to create wall-to-wall maps. How to do this? We had I would like to put here some for those who are interested in having more information. I have some papers related on this kind of application. So we have a number of different techniques for combining Earth observation and data. So you can see different methods. where we can combine satellite data with field observation, or we can also combine Earth observation coming from multiple sources, also from drones, for example, that are sometimes acquired also with the sampling design. So a very large number of possible methods, but more or less coming all from the same concept. So here an example from Italy. I work in the team of the National Forest Inventory in Italy to create maps of the forest variables that we collect in the field. So here you can see our field observation coming from 7,000 plots acquired on the basis of the sampling design. On the left, you can see the dots that are colored on the basis of the growing stock volume, and on the right, on the basis of forest types. So Italy is a quite complex situation because of the latitude, because of the distance from the sea, because of the orography. We have a lot of different ecological conditions, so a lot of species, a lot of tree species, a lot of different types of forest management. So it's a quite complex condition. So here are some example of the data that we need. As a starting point, we need a no-forest mask. This is a tricky point because the forest mask must be developed with the same definition of the forest definition that is used in the National Forest Inventory. So in Italy, we use the FAO definition, so half an hectare, 10% of cloud coverage, and 5 meters height of the trees. So the forest mask coming from the remote sensing must be consistent with the same forest definition that we use in the field. So then we need the predictors. Okay, so the input data that we use for creating the models. So for example, this is from Sentinel-2, from Sentinel-1, and then at the end, this is a point where we can use the WEkEO system. So we can use different methods for Italy. For this application, we use R as a way for a simple code for acquiring the data from the Copernicus platforms. The system that we use is a CART, is a classification and regression tree. We don't have time to go in details, but you have the slides where you can go through the methods. The methods is very well known. The algorithm is the random forest from Bremen. So it's a very well known ensemble learning model that is used to predict the variable on the basis of the predictors. It is important to include in the predictors also the harmonic metrics that we can calculate from the very dense time series coming from Sentinel-2 imagery. So this is a very important variables that we can include in the model. Of course, we have to evaluate the different models that we can try to set up, so to optimize the models. And this performance evaluation is carried out on the basis of the sampling data that we use to create the model. But in order to avoid the overfitting, we use the leave one out cross-validation procedure. Once again, we don't have the time to enter in details, but it is very important to remember that to do this operation, we cannot exactly use the same data that we used for creating the model, but we need some kind of procedure for splitting the data. So this is very important. But at the end, when we are happy of the model, then we can run the model, and then we have the wall-to-wall map of the forest variable that we want to create. And this is an example of the growing stock volume map that we created. Oh, this is also published already. So we have some papers where we describe this procedure in details. And these are just some nice maps of the growing stock volume map that we created for Italy. As you can see, it is masked on the forest non-forest mask. The point is, and you can see the point of the national forest inventories over there. But now, what we can do with this data? So why we create the map of the forest variable? It is important to remember that this is not something from me, but there is a consensus in the community of the people doing remote sensing with National Forest Inventory. Please avoid the use of the maps at single pixel. So because the specific pixel of the prediction of the map can have consistent error. But if we aggregate some pixels in what we call usually small area estimation or model assisted estimation, then we can have a very good estimation for a small area that we call usually forest unit. A forest unit that can be used also for forest management. So you can see here in this picture our growing stock volume map, and overlaying with forest management units. So you can see you can extract the statistics from the pixel for each forest management unit just on the basis of the National Forest Inventory. So what we can see what we can say is that Earth observation can be considered a kind of bridge between the National Forest Inventory, that is something that was originally designed for forest planning, for large region estimation, down to the small area estimation that is needed for forest management. So in this moment, we are not using yet the cloud computing infrastructure that is offered by WEkEO. We are using a different cloud infrastructure, but for the future, we hope to be able to use this WEkEO cloud computing infrastructure. Thank you.
Thank you very much, Gherardo, for your nice presentation. So we will move on to the Q&A. So the first one is about which algorithm is best for land use and land cover classification based on the current evidence.
This is a tricky question in the sense that algorithm should be adapted to the local conditions. So it's difficult to say an optimal algorithm for everywhere. So what we do in a research activity is to try different algorithms to see if they work, which one work better depending of the predictors we are going to use and the condition of the forest area. It's also important to remember that sometimes we use this ensemble approach. So we are not just using one model, but we use the prediction from different models, and then we vote the different methods. So this is a method that can be used also for land use, land cover classification.
Okay, thanks a lot. So this question, I've been hearing forest all the time. What is the definition we stand by here? Are green places in cities or unused lands covered by vegetation considered?
Okay, the official forest definition that we agree at international level is coming from the FAO, coming from a very long discussion on forest definition. So now we agreed on the forest definition that exclude the forest in agriculture and urban areas. But this is something that we can do with remote sensing. I mean, even if official statistics of forest are not taking into consideration this area, you may be interested in estimating, for example, ecosystem services in urban forest. So there is not problem to expand the estimation also in these areas. So there is no technical problem in expanding in other green areas, but that are not considered officially forest according to the FAO definition.
Okay. So, and we also have this question about what does Italy define as forest area, height of trees and canopy cover. So I guess you used the general definition, obviously. Yeah.
Yes. The official definition of FAO, that is also the definition we use in the National Forest Inventory in Italy, is half an hectare, so a minimum size of half an hectare with a 10% of tree cover, and the trees are those that are able to reach the 5 meters height at maturity. So this is the official definition of FAO.
Okay, thanks. This question about if you are incorporating seasonal variations in your dataset when training the RF model. If so, does it have a positive impact on the performance?
Yes. Traditionally, we don't use this information in this kind of estimation. So we are just taking the data from Earth observation coming from the top seasonal condition that typically in Italy is around June, something like that. But it's true that nowadays we have more data available. For example, from WEkEO, we accessed this phenology data set. So we are now developing a new, we are trying to incorporate phenology also in this modeling. For the moment, we are not achieving very strong changes in our estimation, but it's something that we still have to work on.
Okay, I see. Thanks a lot. This question about how do you incorporate forest disturbance mapping? Is it the subtraction of 2 forest cover maps, or are you able to calculate it directly from your model?
Yes, is the second. I mean, we incorporate these trajectory maps, the temporal trajectory maps. Well, the temporal trajectory indicators, variables that are calculated through these methods as predictor of our estimation. So there is another problem that is related to the that we have to be consistent in the time series of these maps, because every National Forest Inventory is updated regularly, and so also the maps have to be updated regularly, and we have to take into consideration that the data must be consistent also in the maps. So this is a problem that, but there are several techniques to solve this problem, yeah, for the moment, we incorporate the temporal trajectory as predictors.
Okay, thanks. This question about if the forest inventory is done in Italia or whole of Europe. Also, I see some missing inventory on a small island in Sardinia. So I don't know if you know that, I guess.
Okay, I don't know which small area is from Sardinia, because this is depending just of the forest mask. So we can do the estimation wherever we want. We just need the forest, non-forest mask. But regarding the whole Europe, this is an interesting question, because the problem is that we don't have a pan-European data set of national forest inventories yet. I mean, this was done in some research projects. For example, the Joint Research Center of ISPRA, they collected and harmonized a large data set of national forest inventories across Europe to create a forest biomass map of Europe. You can download from the Joint Research Center website. But that was done for a specific project, so it's not regularly updated yet. So yes, the problem of creating a consistent pan-European mapping of forest variables is still active. There are several research projects working on this. So I hope that in the coming years, we will finally have this kind of pan-European products. But for the moment, it is not available. It's not. I don't think we will have it in a couple of years. I mean, we will have more times because national forest inventories are difficult to be standardized because they are very different in the different countries.
Okay, I see. Thanks a lot. Okay, so we have time for a few more questions. So what is the best algorithm for forest phenology, and which remote sensing data will be best for deciduous forest? So
for the moment, the best variables are coming from the Sentinel-2 data set, because we have 3 satellites on the same orbit, so we have very frequent observation, and the resolution of 10 meters is good enough for this. And regarding spectral trajectory, I think you can give a look to our slides. We have some reference so you can pick the methods from the papers.
Okay, thanks. Okay, one of the questions is about today's presentation on downgraded models to pure Sentinel, WEkEO, and open data sets, or is it still commercial data sets that are used? So you used WEkEO data?
No, we use just Copernicus open data set. We didn't use any commercial data for this application.
Yeah. Okay. Okay, I think we have time for 2 more questions. So can you use, I guess, the models in predicting the regenerative status or capacity of the forest to sequester CO2?
This is a difficult question in the sense that we can we can map all whatever is the variable that is measured in the field. So if you measure something, then we can try to estimate with remote sensing. So this is the basic concept. Then on the basis of the map that we provide, then we can create other models that can simulate the carbon cycle, for example, like biogeochemical modeling. So it's not directly these methods that create this kind of fluxes, but our data can be an input for biogeochemical modeling that do this job of calculating the fluxes.
Okay, okay, thanks. And so I think it will be the last question about how to differentiate the forests which are covered under snow to the normal ones. I guess you have flagged.
Yes, this is a basic pre-elaboration. This is part of the basic pre-elaboration step. When we do cloud removals, because the main problem is removing the clouds, then we also have to remove the area covered by snow, and that are replaced by clean pixels. There are several methods. Now we use this best available pixel approach, but it is also true that clouds and snow are easy to be detected by optical remote sensing. So it is a basic pre-elaboration step that we do.
Okay, thanks a lot. And so this one will be the last question. So did you consider super resolution on Sentinel-2? I guess it depends on the area you study, maybe?
Yes, our maps at the end are produced at 23-meter resolution, even if we have a higher resolution in the input data, because the 23-meter resolution mimic the area of the sampling plot used to measure the variable in the field. So this is also something that is coming from literature from 20 years ago. There is no reason for creating maps at a higher resolution than what we measure in the field. Okay, even if technically it is possible, under a statistical point of view, is nonsense. So we have to create maps of the same resolution of the sampling unit we use in the field.
Yeah, it's true. Good remark. Thanks a lot. So I think it will be all for today. We have still some unanswered questions, but more general, so it will be done in the post-event report. But yeah, thanks a lot, Gherardo, for your nice presentation. And the question